Okay, so core, or we can say for circular section, what is the no tension condition? So in the previous videos, we have started the no tension condition and we have developed an equation for eccentricity, that is E should be less than or equal to Z divided by A. Then we have seen for rectangular section, what are the limits of eccentricity. Now in this video, we will be seeing for circular section, what are the limits of eccentricity. So first we will be starting with the main formula, that is E should be less than or equal to Z divided by A. Similarly, we will be finding Ex and Ey as we have found out for rectangular section. But in this case, you have to see one thing, that for circular section, both Ix and Iy are same. So both Ex and Ey will also be same. So whatever the value of Ex is there, that will be the value of Ey. So you can see here, Ex is equal to Zx divided by A. So let's give the diameter here first. So let's D be the capital diameter, or we can say capital D be the diameter of circle. So Zx divided by A, and Ey should be equal to Zy divided by A. But we know that for circle, both Zx and Zy, these are same. Hence this both Ex and Ey will also be same. So now what is the value of Zx? It is pi d cube by 32 and area is pi d square by 4. So solving this, E should be coming as d by 8. So we have got the value of Ex here. So Ex should be less than or equal to d by 8. That's why Ey should be also less than or equal to d divided by 8, where d is the diameter of given circle. Now let's point here Ex and Ey. This is the centroid. This distance is Ey. Similarly, this distance is Ey. On y-axis, the distance is Ex. On x-axis, the distance is, on y-axis, distance is Ex. Now connect this all the 4 points with a circle. Now we'll just shade this area. Excuse me. Now we'll give the dimensions. What is this distance? This is Ex. Similarly, this is also Ex. Now what is the maximum value of Ex here? D by 8. That means this is D by 8. This is also D by 8. So D by 8 plus D by 8, total distance is D by 4. Similarly, on y-axis, if we try to calculate, this distance is Ey. This is also Ey. This is D by 8, D by 8. Now D by 8 plus D by 8, total is D by 4. So here you can see the middle fourth area, the total diameter is D. So 1 by 4th of the area is shaded here. So the middle fourth area is the shaded area. That's why this is called as middle fourth rule. Now this shaded area, what it is called as? Same, it is called as core of section. So core of circular section. So the load should lie within this core for no tension, or we can say for no tensile stresses to develop. So we'll write here, for no tensile stresses, load must lie within the middle fourth shaded area. Middle fourth shaded area. And what is this middle fourth shaded area called as? This shaded area is called as core of section, or sometimes it is also called as kern of section. Now here one important point you have to note, that what is the diameter for the core of circular section. Diameter of core of circular section. What is the diameter? So the diameter of core of circular section is d by 4. D by 4. So this is an important point here. So in circular section you have to see this derivation. Then you have to remember that it is a middle fourth rule. Unlike rectangular section, it was middle third rule. Then for no tensile stresses, the load must lie within this shaded area. This shaded area is called as the core. And what is the diameter of core? It is d by 4. Again, you should be able to draw this diagram, because this can be asked in the question. That is, draw the core for circular section of diameter 600 mm or 1000 mm.